Alright, so continuing the conversation about multiplying. So again, still using that product rule when we come across exponents, but when we're multiplying monomials, sometimes we actually are multiplying two polynomials together, like for example, a binomial by another binomial. And there's a method that we use called the FOIL method that just kind of helps make sure that what we're doing stays kind of straight. FOIL just means we multiply the first together, the outer, the inner, and the last. So basically when you have a binomial like this, you want to take the two first terms and multiply them together, like A and C gets multiplied together. And then the outer terms, the two on the outsides of the binomials, A and D, and multiply them together. And then the inner, B and C, get multiplied together. And then the last ones, B and D, get multiplied together. So this is just kind of a reminder for us to be able to make sure that every term in the binomial gets multiplied by every term in this binomial. And that's kind of our goal here, is to make sure that we're distributing the terms, but we want to make sure that every term in this polynomial gets multiplied by every term in this polynomial so that nothing gets missed. So we're going to kind of work through this FOIL method a little bit and do some practice with it. So the first example, we're going to take the two firsts and multiply them together. So x times x is x squared. Then the outer, so x times 4 is 4x. And I'm just using addition to combine my terms unless it ends up with a negative, and then we'll use a subtraction symbol. So inner, 2 times x plus 2x, and the last 2 times 4, which is 8. Okay, now we want to check this to see if it needs to be simplified, and in case it does, we do have these two common terms here that need to be added together, and we end up with 6x. And then also we want to make sure that it's in standard form, and in this case it is. We have x squared, 6x, and 8. So that's going to be our final answer when we multiply these together. Nothing else can be simplified. Nothing else needs to be rearranged. Alright, so then we move to the next example. So here again we have first terms, so 2x times x is 2x squared. Outer terms, 2x times negative 5 becomes negative 10x. Inner terms, 1 times x is a positive 1x. And last terms, 1 times negative 5 is a negative 5. Okay, middle terms, we add those together. Negative 10 plus positive 1 is negative 9. Everything else comes down. We've combined our like terms, we've simplified it as far as we can, and then we've checked to make sure that it's in standard form. Alright, so a couple of examples that we can work through here. Let's work through, let's say number 5. Let's start there. So number 5 is another example similar to that second example above. We're going to start with our first terms. 4x times x is 4x squared. Outer terms, 4x times 3 is 12x. Inner terms is negative 7 times x. And last terms, negative 7 times 3. We're going to combine our like terms here in the middle, and you'll start to see a pattern. Most of the time when these are written in these formats, if your binomials look like this, then your middle terms are a lot of times going to be common terms that we need to combine. So 12x and negative 7x becomes 5x. Again, we're already in standard form. We have the highest exponents working our way down, and it's been simplified. There's no other common terms to add together, like terms. So our final answer here is 4x squared plus 5x minus 21. Let's see, we can do another example. Let's do this one that has two negatives involved. First thing we're going to do is multiply the two first terms together. 8h times 3h is 24h squared. The outer terms, 8h times negative 1 becomes negative 8h. So notice I'm going to use a minus sign to combine these now. Inner, negative 3 times 3h is negative 9h. And then the last, negative 3 times negative 1 becomes a positive 3. We combine our like terms, and these two negatives are going to add together. So we end up with 24h squared minus 17h plus 3. We check to make sure it's in standard form. And we've combined all of our like terms, and so that becomes our final answer. Okay, so let's look at just a couple more of examples on the back. Let's look at number 15. So number 15 is written a little bit differently, and common for students to want to do this. A lot of students just want to square each individual piece, and they put x squared plus 16, and that's their final answer. Okay, but that is not correct. What we need to do here is consider what it means to square something. So what it means to square something is to take that term or that expression and multiply it by itself the number of times that we have that exponent. So in this case, we would take x plus 4 and multiply it by itself another time. So what this really means is x plus 4 being multiplied by x plus 4. And that's the key for anytime you see a binomial that's being squared, is we're going to take that binomial and multiply it by itself. So it's really more terms here than just those two that you're squaring. You're going to be multiplying each of these terms by itself. So x times x becomes x squared, x times 4 becomes 4x, 4 times x becomes 4x, and 4 times 4 becomes 16. So there's a whole middle term here that happens that you miss if you just try to square this in this manner. So you end up with x squared plus 8x plus 16. Okay, so things to keep in mind as you're working through these. All right, now, if we do come across something where we go a little bit more extensive, do a binomial times a trinomial, my advice to you would be to take the first term in your binomial and multiply it by all three of these terms. Then take your second term in your binomial and multiply it by these three terms. And that allows you to make sure that every term over here gets multiplied by every term over here. And it's going to be a big long string of things, but hopefully things will simplify back down. You can combine some like terms. So it would look like this. 3a times 5a squared is 15a cubed. 3a times 2a is 6a squared. 3a times negative 6 becomes negative 18a. 1 times 5a squared is 5a squared. 1 times 2a is 2a, and 1 times negative 6 is negative 6. Then we can combine our like terms. So there's nothing to combine with this a cubed, so I'm just going to bring it down. I can combine these two that are a squared. So 6 and 5 becomes 11a squared. I can combine these that have a single a. Negative 18 and positive 2 becomes negative 16a. And then finally we have this constant out here on the end that we can just bring down as a minus 6. And because everything just kind of lined up the correct way, and when I combined my like terms, I did them as highest exponent first and brought my way down, I ended up having mine already in standard form. I've already combined all of my like terms and ended up with a final answer here of 15a cubed plus 11a squared minus 16a minus 6. Now, when we do our geometric application, a couple things to remember. It's asking for the area of the shaded region. So in order to find that, you're going to need the area of, so the area of the shaded region is going to be equal to the total area, because we have this whole box is going to be that shaded area, but we got to get rid of this part that's unshaded. So we're going to take the total area and we're going to subtract the area of the unshaded. So you're going to have to multiply these two together to find that area. You're going to have to multiply these two together to find that area and subtract them so that we can find just the shaded area. Okay, so that should be a little help for you to get that geometric application question started. Now go through these questions, go ahead and work through a few more. Ask your questions if you have them. Make sure you don't have anything that you're struggling with. Just check your understanding on these, and if you do come across any questions, make sure you ask them, and I'll be happy to help you.